Well, good morning, everyone. This is Larry Welch again at the Texas Asphalt Pavement Association. We're coming to you this morning from a couple areas. We've got a real guest here today going to talk to us about the silica. This is a great safety webinar. We hope everybody will listen in and follow this along and tell your friends about it. Again, we do record these webinars so that you can go back and view them at a convenient time for you or the employees that you have that maybe you want them to listen in on these webinars also. You can go to the TexAPA website. I believe it's under Education Webinars, and you can go back and review the library we have, and you can visit these webinars at your convenience. I want to remind you that next month our webinar will be on the 16th of May, the third Thursday of each month at 10 o'clock. Chuck Fuller is going to be along with me. We're going to talk about thin overlay mixtures and thin overlay pavements. This is a great webinar if you're thinking about using thin overlay mixtures. And we hope you tune in at 10 o'clock on May the 16th. Also, I'd like to remind you that Monday, this coming Monday, April the 22nd, we're having a paving and compaction seminar in Fort Worth, Texas at the Radisson on Meacham. That's in North Fort Worth. If you want to call down or get on the internet and sign up for that, we'd really like for you to sign up if you're going to attend so we can have an attendance record and also so we can make sure we get enough food for everybody at lunch. We will be providing a lunch. That'll go from 9 to 4 at the Radisson on Meacham in North Fort Worth. So hope you can attend that. We will have another one in May the 15th in Dallas. Actually, it'll be Garland out on George Bush at the Hyatt Place, and that'll be from 9 to 4 also if you want to call in and register for that one or register on the internet. But today, our webinar is just a wonderful topic that we all need to be concerned about. It's about a health issue that could potentially affect us, or the silica can get into our lungs and stuff. And I have Doug Wilcox with Texas Materials, and he's the environmental manager for the Central Texas area. Doug, thank you for being with me this morning.
It's wonderful to be here. I appreciate the introduction, Larry. Good morning, everyone. As most of you have likely heard, there's this OSHA rule out there dealing with respirable crystalline silica. Today, we're not going to go into a great detail of the rule, but rather we'll cover the high points associated with the topics on the agenda. The agenda, as you see it on your screen, hopefully everyone can see that. It consists of looking at the scope and applicability of the rule, the exposure assessments that's associated with the rule, permitted concentrations of respirable silica, personal air monitoring, and methods of compliance. So, silica, let me kind of delve into that a little bit first.
Hey, Doug, let me remind them right quick that if y'all have any questions, y'all can go to the chat bar there and type those in, and I will monitor those as Doug is going through this presentation. Or you can call into the TexAPA office and leave your name and number and your email address, and I can get Doug or myself to answer these questions that you may have about this if you need some further information. Now, at the end of the slides, there is a link to some more information about this. So, Doug, I just wanted to throw that in right quick. I almost forgot it. And
no
we'll go on to the next slide now, and you can start off and head on out.
Okay. All right. So, silica. What is it, and why is it important? Silica is the 14th element in the periodic table of elements, and is one of the most abundant elements on Earth. So, when atoms of silica crystallize, they form various geological substances such as chrysolite and tridymite. And these two particular substances are what is of concern under the rule. And it also forms silica sand. And then crystalline silica can be found in some limestones, sandstones, granite, shale, clays, and other materials, making it an ingredient in a lot of these raw materials that we use in our industry. So why is it so important? It's the primary building block used in electronics, in making glass, reflective signs, and building and paving products, just to name a few. And of course, our way of life today would be way different without it. But like most chemical substances, too much of it can cause severe health problems, which, as you've heard, is why exposures to respirable crystalline silica are a problem. Silica has been known for decades to cause health problems such as silicosis and various cancers, kidney and liver damage, and has been regulated actually in the mining industry for many decades under the Mining Safety and Health Administration. Only recently has OSHA developed rules for silica control in our industry, in the construction industry. In looking at the scope and applicability of OSHA's rule, the rule applies to all occupational exposures where crystalline silica could be present, such as when sawing concrete, asphalt pavements, when you're sweeping base materials prior to paving, etc.
You know, Doug,
Go ahead.
We've been around this stuff. We've been around this stuff so much. Just mowing our yards, sweeping our garage floors, and things like this over the years. You just think about the damage maybe that we've done to ourselves. Maybe not terminally, but you know, health-wise, could slow us down. But these are all great topics that can help us limit this exposure to these products.
Oh, absolutely. This dusting and just dust in general is something that most all of us are exposed to at one time or another.
Exactly.
Under the rule. Pardon?
You can go ahead. Yeah.
Under the rule, however, it does not cover agricultural operations or processing clay materials because these are covered under different rules. It also does not cover operations where you can show that exposures are at or below the action level, which is shown in the slide as being 25 micrograms per cubic meter over a time-weighted average of 8 hours. And we'll talk a little bit about this a little bit later. Remember then that this would apply, this 25 micrograms per liter would apply under all foreseeable conditions. So you kind of got to look past the task that you're actually doing at the time and look at all of the conditions that might impact that task. So as you can see, this 25 micrograms per cubic meter could be hard to meet. Additionally, it also does not cover those employers that comply with the OSHA construction standard, and you can see the citation there where you can go and look at this construction standard at a later date. Okay. Under the rule, employers must do a couple things here. Assess the employee exposures to silica if it may be at or above the action level of 25 micrograms per liter. The action level determines the level basically where you don't have to worry about exposure and where you need to start assessing if employees are being exposed or possibly overexposed. We'll talk about air monitoring to determine the exposures here in just a little bit. Next slide.
All right, I've got permissible exposure limit. Is it up?
You have exposure assessment.
All right, let me go one more. Now, did it change?
No.
All right, we're having a little glitch here. It shows it changed on my computer here to slide 7.
And
nothing
on mine, no.
All right, well, Doug, go ahead with the script, and I'll see if I can change something here. So we're on slide 7, right?
Here, it just changed. It just
Okay,
changed.
good deal.
All right. Technology's wonderful when it works.
It is.
So,
We'll probably have some weather-related issues outside, probably.
all right. So, what is the exposure limit where we need to start taking some sort of protective measures for employees? That exposure limit is 50 micrograms per cubic meter is the time-weighted average. This is new. This was the previous PEL, or permissible exposure limit, used to be 100 micrograms per cubic meter, and the OSHA changed that, cut it in half, and brought it down to 50 micrograms per cubic meter. At or above this level, a plan has to be in place to address respirable crystalline silica in the workplace. In other words, if you're above this level, then you've got to provide some sort of protection for your employees, and we'll go into those here shortly. In making your assessment there are a couple of options.
All right, so let me change this. All right, now, see if it changed.
All right,
there we go.
The first is a performance option in the rule that gives employers the flexibility to determine the 8-hour time-weighted exposure for each employee based on any combination of air monitoring data or objective data that can accurately characterize the employee exposures to respirable crystalline silica. The data must reflect workplace conditions. You can't just go and do your monitoring in the at the office and then go out in the field and assume that your employees are being exposed identically. The data must reflect the workplace conditions that closely resemble or could result in higher exposures than the processes, the types of material that are being used, the control methods that you're using, the work practices, and the environmental conditions that may be present in the employer's current operations. So you got to look at your job. You've got to look at all of the conditions and factors that are there that could provide an exposure to the respirable crystalline silica at the workplace. The second, and this examples of the objective data are information such as data from industry-wide surveys. This would be data that you could gather from different types of literature that maybe have looked at situations where your employees are facing. In other words, someone else may have taken some measurements where they were doing sweeping or saw cutting, and that might be the same thing that you're doing, and therefore you could use that data there to say, I guess I'm not exposed, or I might be exposed. You could use calculations based on the composition of a substance. In other words, what we mean there is, okay, if you're using a particular kind of rock in your hot mix, that rock may or may not have crystalline silica in it. The limestone may not have respirable crystalline silica. So calculations of that sort could say, well, then I don't have an exposure. I shouldn't have an exposure. You could use area sampling results and exposure mapping. And you can use historical air monitoring data that's may have been collected by you as the employer in previous operations. So
that's all good data to have there. Those are good topics that all of us need to take charge of. Yeah. All right.
Yeah, it's awesome. It would be very good data to have, because OSHA's, if they come out to the site, what they're going to do is they're going to look at you and see what you're doing. And we're going to talk about an exposure control plan towards the end of the program that'll help you with your decisions as to when and how you're going to have to do control. There is a second option, schedule option, and that is scheduled monitoring option lets employers know when and how often they must perform exposure monitoring to measure employee exposures. In other words, how often are you going to have to do that, and why.
All right. You want me to stay on the assessment schedule monitoring option slide?
Yeah, next slide, please.
All right. There we go.
Exposure monitoring must include, at a minimum, one full shift taken for each job function in each job classification, in each work area, and on each shift. So your shift can be 4 hours, it could be 6 hours, it could be 8 hours, it could be 10 hours. Whatever your shift is where you're going to want to do that exposure monitoring, and it's going to require you to do that sampling. And as I indicated before, we're going to talk a little bit about air monitoring in just a few minutes. Then,
all right.
Then if the initial monitoring indicates that employee exposures are below the action level, again, this is 25 micrograms per liter, then no further monitoring is required. So if you go out and monitor and you get the results back and you go, okay, it's less than 25 micrograms per liter, then I don't have to do anything. You're not exposing your employees. However, if the most recent exposure monitoring reveals employee exposures at or above the action level, but below the PEL, which is the permissible exposure limit, the employer must repeat monitoring within 6 months of the most recent monitoring. So if you monitor tomorrow, then sometime between tomorrow and 6 months from tomorrow, you have to repeat some monitoring. Okay, and if you come up with the same results, then and they are below the action level, then you don't have to do anything else. If the most recent exposure monitoring reveals employee exposures above the PEL or the permissible exposure limit, remember this is 50 micrograms per liter, the employer must repeat monitoring within 3 months of the most recent monitoring. So you've got to do more monitoring, basically is what it's saying.
I see.
When 2 non-initial monitoring results taken consecutively, at least 7 days apart, but within 6 months of each other, are below the action levels, like we were talking about before, the employer can stop monitoring for employees represented by those results. So as long as no changes occur that could reasonably be expected to result in new or additional exposures at or above the action level, and again, 25 micrograms per liter, then you can stop that monitoring. So you can see that if exposures can be controlled to below the action level, then it's both to the employer's advantage, obviously, and to the employees themselves, in that they are not going to get overexposed.
That's good stuff. Now the next slide shows questions. We will take those at the end, or you can call in. So I'm going to go ahead and click the next slide.
There you go.
All right, there we go, silica.
We've been talking, of course, about the exposure levels, and I've talked about 25 micrograms per liter and 50 micrograms per liter, which begs the question, basically, what is 25 micrograms and 50 micrograms per cubic meter mean? I mean, what does a cubic meter look like? So here's a graphic representation of a cubic meter, and the cubic meter is the white cube, is 3 by 3 by 3 roughly. So that represents that the air in that cube represents a cubic meter of air. Looking at the green item on the floor, that's a cubic foot, just to kind of give you a contrast of a cubic meter versus a cubic foot. in the photograph on the right, you have the cubic meter, but then I put a dry erasing marker in there to kind of give you a contrast. So now basically you can tell everybody that you've seen a cubic meter of air. That's a cubic meter of air. Awesome.
All right.
So let's go to the next slide, and then what we'll do in this next slide is I'll kind of narrate what you're looking at. Now, to give you an idea of what 50 micrograms looks like, I'm taking a powder of 1 gram of powder, and in this case it happens to be Splenda, and then we divide that in half and push some aside, and then we take what's left and divide it in half. And in this video, short video, you'll see the idea here is to show you what 50 micrograms might look like. And so we'll go through it kind of quick here in a few minutes, but you're dividing everything in half. And after about 12 divisions, you're down to a point where we're going to try and divide it in half again. And that little dot right there would probably be close to 50 micrograms of that powder.
So it's a very small item.
It's very, very small because it shows you at the tip of that razor blade how small that is. So now, when you mentally take that little dot and put it into that white cubic meter, and you'll see what basically kind of gives you a very good perspective of what 50 micrograms per cubic meter would look like. That
I've seen you
over that dot.
Do that before, Doug. That's really good.
That is not much. That is not much.
Not much.
So
at all.
You can see that if you were over that dot, that if your employees are exposed to a level greater than that little dot of material in that cubic meter, then technically they're being overexposed, and you've got to do something to protect them. So what we're going to do is we're going to look at sampling, because you're wanting to look at their exposures, and you're wanting to monitor the air in their breathing zone. And so we're going to look at some personal air monitoring. Okay. So the air sampling not only determines the exposures, but it also shows the exposure of the respirable dust to the worker. It determines the exposure limits aren't exceeding OSHA's action levels, whether it's 25 or 50 micrograms per liter. It talks about showing if your engineering controls, and we're going to talk about those here in a little bit, are working effectively. And it'll also tell you what type of respirator is needed if that's something that you're going to have. So who can perform air sampling? Basically, a safety specialist, maybe within your organization, maybe a consultant that can do that sort of thing. OSHA personnel can also perform air monitoring, and an industrial hygienist can also perform air monitoring. Many of you may have insurance with a large company, maybe Texas Mutual or Liberty Mutual, something of that or that caliber. And generally those insurance companies have industrial hygienists on staff that can perform monitoring for you. Generally, it's free because your premiums are paying for that. So that's a resource that you can take a look at first, and that's what I would recommend, is that you look at your insurance resources first, and then look outside for maybe consultants that can help you with your air sampling.
Excellent, excellent.
So who should be sampled? Basically, you need to select the highest risk employees, which for our industry would likely be those workers who are closest to the source of respirable dust, and that would be things like cutting concrete, sweeping roadways, grounds, cleaning out bag houses at your hot mix plants, jackhammering, cleaning the drop chute or the drag, and or driving a loader or some other mobile equipment that does not have an enclosed cab with filtered air. So those are the people that you would want to be looking at. If you've sampled the workers working closest to the source of dust, and they are not exposed, then most likely all the other workers in that area will not have an exposure issue either, or they won't be significantly overexposed. That would be like if you've sampled a ground guy who's working around a sweeper, and you come up with a less than 25 micrograms per cubic meter of respirable crystalline silica. And I need to emphasize that it's not the amount of dust. We're looking solely at respirable crystalline silica. And if you'll remember back when I was first talking about this subject, that they would be looking at the cristobalite and tritomite and those types of things as being the bad actors, if you will, for respirable crystalline silica. So that's what they're looking for. So if you're not exposed, if these guys are not exposed, then more than likely the rest of your crew is not being exposed. Next slide. Okay, we talked about the applicability of OSHA rule, the exposure and concentration as related to respirable crystalline silica and how to measure it. But how can we control the substance and exposure in the workplace? Better to control it, obviously, than to be overexposed, right? So let's look at the methods of compliance or ways to control exposures, okay? We'll talk about, next slide.
There we go.
There we go. We'll talk about methods of compliance. We've got engineering controls, we've got administrative controls, we've got respiratory protection, and as a part of that whole compliance program, we'll talk a little bit about a written exposure control plan that's required. So let's look at engineering controls. Engineering controls are basically designed to engineer out, if you will, take away the hazard, eliminate it completely. So if you're looking at, say you've got a guy on a loader and it's kind of dusty and there's some issues associated with respirable crystalline silica, then you can engineer out and wouldn't have to monitor if that guy, if that loader has an enclosed cab with, like air conditioning or some sort of ventilation that's filtered. So what you've done is you've taken that person and put him in an environment where the hazard has been eliminated, and that's what they're calling engineering controls. In this case, it could be use of water spray or a drench at the point of dust generation, or the use of vacuums equipped with HEPA filters. So those are engineering controls that take away the hazard and therefore the exposure. Next slide. Some examples of an engineering control, and you can see here, jackhammer used without engineering controls. You can look at the dust that's around, and there are several employees that are in the area that are being exposed. When you put the water spray to it, you control the dust. This guy still has a dust mask on, which is fine, but he may not need it, assuming that they've taken away, based on this photo, taken away the hazard. In other words, no dust. Next slide. Here's saw cutting, without dust control, and then using water to control dust while the saw is cutting pavement. You can see the guy, he's pouring water down there. And basically what you've done is you've taken away the hazard. That's the best way to address respirable crystalline silica exposures. Okay. So the next thing that you can do is you can have administrative controls where you're controlling the work practice or the work task. These types of controls minimize the exposure time to a dusty environment by maybe rotating people out or out of the environment or the exposure zone. You have inspection processes. You have maintenance. In other words, you're looking at your equipment, and if you have air filters, for example, in a loader that's got an enclosed cab, you're maintaining those filters so that they don't get clogged and that they're doing the job that they're supposed to. You're inspecting the job sites. You're trying to figure out if there's going to be an exposure problem at the site, and maybe you can do some things that you can look at and maybe do it at a different time of day, or you can do it right after it rains, or whatever. Scheduling, we just talked about in terms of rotating employees in and out of the work area. For example, if you have an employee who's working next to a sweeper or in an area where they're creating a dusty environment, then that person only works there for maybe 30 minutes. And then you rotate that person out to an area where there is no exposure. So this is all predicated on a time-weighted average of 8 hours. In other words, an employee has to be in an area for a full shift. Could be 8 hours, could be 10 hours, whatever that shift is. And then based on some algorithms, then during the measurement of the respirable crystalline silica, they can establish a time-weighted average. So if a guy is not exposed a total of 8 hours a day to 25 micrograms or more, then you don't have to do monitoring. So it's all based on that exposure being exposed for 8 hours. So if the guy is rotated in and out, then you reduce the exposure of that person over an 8-hour period. And then finally, another administrative control is training, Okay. We just talked about this, inspecting, maintaining engineering controls. We just talked about all of these, wetting down silica dust before sweeping it up, positioning local exhaust hoods if that's something that you can do. Maybe that's in a shop or in an enclosed area. We talked about scheduling. Okay. The other thing that's required, both of this rule as well as in OSHA's HAZCOM, and most of you probably already know this, employees must be trained at the time they are assigned to a position involving exposure to respirable crystalline silica. Employees need to be able to recognize the hazard and how to control it. Okay, the employer must ensure then, of course, that the employees can demonstrate knowledge and understanding of at least the health hazards that are associated with this crystalline silica. The task, they have to understand the task that could expose them to the respirable crystalline silica. And they need to know about measures that can be implemented to protect them. Now, that's engineering controls, that's administrative controls, and that then any kind of PPE that they might be required to wear. They need to know about the contents of the standard, and they need a purpose, understand the purpose and description of medical surveillance program, and we'll talk about that here in just a few minutes. The other administrative task is housekeeping. Where cleaning can contribute to employee exposure to crystalline silica, the standard requires all employers covered by the standard to avoid certain housekeeping practices. And this would be things such as dry sweeping or using compressed air to clean or dust off clothing or other surfaces. So per the slide here, you can see, do use housekeeping methods that don't create airborne dust. If you're dry sweeping, maybe you can use a small light spray of water to keep the dust down. Maybe if you're in a shop or you're around the hot mix plant, maybe what you can do is use a dry sweep compound. Those are all available, and those all keep the dust down. What you don't want to do is what we just talked about, is to dry sweep. As a last resort, personal protective equipment can be used to reduce exposures to respirable crystalline silica. PPE is always a last resort. Like I said, engineering out the hazard is the best way. Administrative tasks are also another way. A combination of administrative and engineering controls is the next option. And obviously then the last option is, if you need to, the person needs to be wearing a respirator, okay? So when using or requiring employees to use respirators, be sure to show them how to properly put on the respirator so that it fits the face, and how to take it off and store the respirator. Most of these respirators are meant to be used only one time. Some can be used, depending on how contaminated they are, can be used 2 or 3 times. But the important thing is educating the employee as to how to put and fit the respirator to the face. There are some people who have very little nose bridge, and that's going to require a little different fit test. Some who have mustaches and beards, that's going to present another problem, because you'll never get the proper fit of the dust mask or the respirator if you have a lot of facial hair. So you need to take that into consideration. Okay. Let's look at some administrative tasks. There are a couple of primary administrative tasks that you should address. First one, and we talked about this just a second ago, was medical surveillance. The employer must offer medical exams, including chest x-rays and lung function tests, every 3 years. And that's for employees who are exposed above the permissible exposure limit. Remember, that's 50 micrograms per liter for 30 or more days a year as of last year. So that we should already be looking at that. So if you're requiring your employee to be in an area where he or she is going to be exposed for more than 30 days per year at or above the PEL of 50 micrograms per liter, then you need to offer medical exams for that person every 3 years. Then starting in June of 2020, you need to do the same thing for people who are going to be at or above the action level for 30 days or more a year. So as you can see, the best thing that you can do as an employer is to control the amount of respirable crystalline silica that employees are exposed to, and control it to below the action level of 25 micrograms per cubic meter. There are some necessary actions that you'll have to take. As noted earlier, if the initial exposure monitoring indicates that exposure is below the action level, you can discontinue monitoring. And then again, if exposures above the action level are between it and the PEL, then you need to resample in 6 months just to confirm that that's what it was. And then if you have exposures above the PEL, then you need to resample then within 3 months and keep these records. Okay. Speaking of record keeping, be sure to keep records of your exposure measurements, any objective data, as we talked about earlier, that you might have, and medical exams. These medical exams have to be kept for a long time, and they need to follow the employee. Okay, so it's best if you, as the employer, then obviously can control exposures to below the action level to avoid medical surveillance. Medical surveillance is something that you really don't want to be involved in, so it's to your advantage to control those exposures to below the 25 micrograms per liter. And I know I've said that several times in the program, but I can't emphasize it enough that by using engineering controls and administrative controls, those are your best ways of not having to have a medical surveillance program and all of the things that go with that. And of course, that benefits the employee too. So, right. How are we going to do that? You need to develop a written exposure control plan, or I'm going to call it ECP for short. This is a requirement. It's a plan that describes the workplace task that the employees would be involved in. It's generated primarily for use in the field or at the plant, or a combination of that. It's a description. It gives a description of the engineering controls that we talked about, work practices, respiratory protection that may be used to limit employee exposure, and it also gives a description of the housekeeping methods that are used to limit exposure. Next slide. Looking at the ECP, the written is going to need to have the scope of the plan, describes the projects, you can read that. The regulatory review, in other words, have some links, if you will, or some description of where you can go and get further information in the literature for the rule. The training requirements, it discusses the type and content of the training that the company will provide to its employees. Medical surveillance requirements, which we were talking about just a few minutes ago. Competent person requirements. Now, we didn't say much about a competent person, but the competent person has some training that they need to go through that's a little more advanced than the normal worker or a normal employee. The competent person needs to be able to look at a task or look at a work site or job site and be able to determine that, yeah, there's probably going to be some exposures here that we need to look at to the respirable crystalline silica. So they get a little bit more detailed training, and some of that training is described more in the rule. And they will be able to address some of the questions, or should be able to address some of the questions that the employees might have when they actually get out into the work site and on the job. And finally, the ECP, or exposure control plan, will discuss what the company is going to do to assess exposures. This is the written document, and this document is probably one of the things that OSHA would require should they come up and do an inspection for your site and want to look at your exposure control plan as a part of protecting the workers from respirable crystalline silica. Okay. The plan also has to be reviewed or copied by employees. It has to be available, basically, to those employees, a designated representative or representative from OSHA or an IOSH if they should show up. And these should be available, this plan should be available somehow or another. It could be on computer, online, it could be in a paper form, but it has to be available for review by pretty much anybody that wants to look at it. The plan also must be reviewed once a year. This is a good practice with all your policies and procedures, is just to make sure that it's still applicable and that it's accurate, that names haven't changed, from when it was first written, and maybe you're not doing some tasks that you used to do. So it's always a good idea to review the plans and procedures. In this case, it has to be reviewed once a year. So let's look at it. Let's look at an example of an ECP. This one's based on Table 1, and you can see at the top, it's a hot mix construction crew silica exposure control plan. This is based on Table 1 that's in 1926.1153. That's the Code of Federal Regulations that are the rule for the silica. And you can see here, in this case at the top, we're looking at, we've got an equipment or the task, we've got engineering and work control, work practice control methods that are listed. Sometimes manufacturers have control methods that should be used by the end user or the employer and the employees. And then at the end there's a required respiratory protection that based on less than a 4-hour shift or greater than exposures to greater than 4 hours per shift. So looking at the first one, there's a small drivable milling machine. It's less than a half lane. A lot of us use those to clean up small jobs, patch jobs, maybe edge milling and that sort of thing, and cleaning up after that. In this case, the machine is equipped with supplemental water sprays that are designed to suppress dust. If you look real close, you can see the water tank is on top of the skid steer. And you can see over to the right-hand side that if it's got water sprays, then there's really no requirement to use any kind of respiratory protection, because basically what you've done in this case is engineered out the hazard by using water to control the dusting. But if you don't use water sprays, then you should use an N95 respirator, which is what we showed you back when we were talking about PPE. A lot of us use the large drivable milling machines, half lane and larger. These are big. A lot of times you contract that out. Some of you may have your own milling machines, but you can see there the engineering controls. If you can't control any of the dust emissions using water in this case, then you need to go over and it shows you that you need to use an N95 respirator. In this case, Road Tech, they have spray bars to inject water into the cutter housing. It shows that the front spray bar is primarily for dust suppression. and then the rear, of course, is for cooling, but it also helps to suppress dust. A lot of the newer machines are coming on with a vacuum system to help when they're conveying the millings onto into a dump truck. Next slide. This is an example of the power hand saws. We looked at those a little bit earlier. Basically, again, it talks about using water to control dust. That's going to be your best friend in controlling dust on the work sites. Next slide. And these are just a few more tasks. Jackhammering. A lot of times your shops will use chipping tools to chip out asphalt that's or hot mix that's been cured inside like a cocal or maybe another piece of machinery, the pavers. And so they should be wearing a dust mask if they're not able to control the dusting that's associated with the chipping. And in some cases, this would be using a vacuum system of some sort. That's something that you'll need to look at for your shop folks. We talked about the brooms. Next slide. And you have the sweeper trucks. There's these guys, they really have an exposure potential, big exposure potential. It's just like the guys driving the little brooms and that sweep the job sites. You'll really want to take a look at these types of employees. Drags at the hot mix plants, they're the drop chutes. If you can minimize the amount of distance that you drop the clean out material, you'll reduce the amount of dust. You can see here that there could be a water spray that could be used. In this case, there were some old conveyor belts that were used to help control and guide the material to the ground. So your ground guys are going to be an exposure potential here. And then, of course, we talked a little bit about loaders just a little while ago. Okay, next slide. There's, if you need more information on the standard, you can go to www.osha.gov/silica, and that'll take you directly to the standard. Or if you've written it down, you can go to CFR 29.126.1153, and that'll take you directly to the standard also. So
and Doug, this is some great information. I know you spent some time on this. I really appreciate it. Thank you for coming on the webinar today. I want to thank your employer, Texas Materials, for allowing you to spend an hour with us. Again, if you've got some questions about this particular item, give TexApp a call. You can talk to Emily or Kelly. They'll take the information down and pass it on to me or Doug, and we'll get back with you. Again, Doug, thank you so much for being with me this morning, and have a great rest of your day.
All right, thank you.
And we want to thank the audience that attended this morning. Again, this is Larry Welch for TexApp, and we're going to sign off at this time. Thank you very much.